Hello everyone, welcome to Blackhat Arsenal 2023. My name is Islam Salim, I'm a security research lead at Datadog. And today I would like to talk to you about our Honeypot framework, Hash. A little bit about me, I'm working at Datadog as a team lead of security research. Previously I worked at Screen and before that at Shieldify. I'm focusing on application security, cloud security, and vulnerability research. When it comes to honeypots, there is three main types of honeypots: high interaction, medium interaction, and low interaction honeypots. Each of them has its own objectives. So for example, high interaction honeypots, we deploy the full vulnerable system in an isolated environment. The objective here is to collect every tactics used by attacker, especially the tactics used after they compromise the system. On the other hand, there is low interaction honeypots. We actually simulate the behavior of the vulnerable system instead of deploying the vulnerable system itself. The objective here is different. We collect the initial payloads and exploits used by attacker, and we can discover 0 days and collect more intel. On the middle, there is a medium interaction honeypots, which actually still simulating the behavior of the vulnerable system, but with adding more if interactions. When we thought about building a honeypot, we thought about 4 criteria. We needed the honeypots to be fast for building and deploying the honeypot. We wanted to be fast to respond to emergent vulnerability and emergent threats, so we can deploy vulnerable application fast. We also needed it to be highly customizable, so to emulate any kind of programming language or web server. So for example, if you want to emulate a PHP application, Go application, .NET application, we wanted to use the same honeypot framework. And also if we want to emulate Apache, Nginx, IIS, Tomcat, we wanted to use the same honeypot. We wanted also to be undetectable. Instead of using defaults, we want randomization and random data. And of course, we wanted it to be easy to collect logs, traces, and other telemetry data. This is why we build Hash, to be a single framework to deploy HTTP and HTTPS low interaction honeypots. We wanted also to be easily configured, so we developed sample YAML file to be the main configuration of Hash. And of course, powerful randomization. We used Faker.js to provide this randomization. The objective is to avoid honeypot detection. And of course, it's open source and free to be used by anyone. Let's talk about the first item, easy configuration. The main configuration of Hash contains in a folder. This folder contains init YAML, and this init YAML holds the main configuration of the honeypot. Also contain a folder called templates, which hold the request templates, and there is a subfolder resources inside templates contains a static file, JSON, HTML, CSS, and images files. This is the content of init.yaml. It contains the honeypot name, the port, and the header you want the honeypot to expose. So in this example, we are simulating Apache version 2.4, so we exposing the server header. We can also expose any kind of header inside this YAML file, and it will be exposed by the honeypot. Let's take a look at one request template. In the request template, the first part is the meta information, contains the ID and the title for this template. The second part is requests, with actually an array that contains multiple requests. In the request itself, it contains 2 parts. The first part expect, which request matching criteria. So in this example, it matches get request on this path /author/ID. The ID must be an integer. defined by this regex. The other part is reply, which actually the reply the honeypot should return if the request matches. In this example, it will return the content of author.html. The second feature is randomization. We mentioned that we are using Faker.js under the hood. Faker.js has a powerful JS library that can randomize data. It contains a lot of functions for generating numbers, names, addresses, you name it. You can check the documentation for more details. But randomization by itself is not enough. So for this example, we have a user API.json and we have multiple functions. So randomized name, email, URL, and on the right, this is the final version after randomization. But if attacker every time they are using they are visiting the URL, it generates random data. This is a highly indicator that this is a honeypot, and actually this is one of the methods used by attacker to identify honeypots. This is why we are combining cache with randomization. So for example, if an attacker visited this URL, API user 5, and we have a function for randomization of the name, it will generate a name. And every time attacker visits the same URL, it will return the same name instead of generating a new one. But if the URL changed, so like API user 6, it will generate a new name because this is a new user. This simulates the normal behavior of an application. The final feature is logging. Hash support 3 type of login right now: console output, file, Datadog. We are trying to log every information that can be helpful, like request, attacker information. Please feel free to let us know if you want us to support a new logging type or make a PR. The contribution is welcome. And now it's the demo time. Let me switch to terminal. You can install Hash by using npm install or docker pull to pull our already built Docker container. Once installed, you can use -cli command in your terminal. So if we type -cli help, this will list the available commands for Hash. You will find two main commands here: run and generate. So if we have a look at generate commands, this is to generate a honeypot profile. It takes one required argument, which is folder, and there is a couple of options. We will have a look at it in a second. Let's generate our first honeypot in a folder called honeypot1 based on the default templates, and let's call it first honeypot. Now it's generated and it's stored in the folder honeypot1. Let's have a look at the content of this folder. You will find init.yaml contain the name of the honeypot, the port, and the headers. This is the default server. You can list a new headers if you want and change this. There is a couple of default templates here. There is default.yaml. This is the default route, and 404 to catch like every request that's not already added in any other template. Resources folder, which contains the static resources. Let's run this honeypot and see how, like, what we will see. Run honeypot1. Okay, honeypot is running. Right, this is the first page content, of course, random content. Let's have a look at more interesting endpoint. We have user/1. This is an API endpoint, return a JSON file with random data. So if we have a look at the template that's able, like, the responsible to generate this is api.yaml. If a user, an attacker like navigate to this user slash user ID, which is random, it will generate the JSON file. JSON file contain a couple of randomized functions. But if you notice, there is one special parameter here, is param user ID, which is actually what it's defined here, and this is the ID, because in application you expect that the ID is in the JSON itself, the same ID, it's not another number. So if we have user 2, you will find the ID is the same as the parameter, but other parameters like name, URL, any other is randomized. And of course, because we are using cache, this is the same content for each endpoint. All right, but if we edit like a non-existent route, it will generate a 404 not found, which is defined here. Of course, you can like change the content, emulate any not found page, for example, like Spring Boot not found, or a Laravel not found. Whatever you want to simulate, you can simulate it easily here. All right, let's try another thing. So let's set up a SQL injection trap. So typically, if someone wants to test SQL injection, they will like generate it's instead of integer here, they will like try to insert like a SQL injection payload. So let's do this. Another request, of course, because we want to log this as a malicious, we will add is trap true, and here we're gonna remove the regex to catch everything, and instead of view, let's return content right away and add the default error for MySQL. This should be enough to simulate the error, like condition. We can use text slash HTML here. Let's restart our honeypot, and for here, if we add an integer, this is responded well. But if we do something like this, users, so we will get error in your SQL syntax, and here we log as the request as malicious with all of the information. All right, now let's jump to a new feature. We happy to announce it here at Blackhat, which is the ability to build a honeypot based on Swagger configuration file. Let's have a look at normal Swagger configuration file. Here we have a sample for Swagger configuration. So it contains a couple of endpoints for pets, get, post, and pet's name, get. If we have a look, this is have some definitions like bit and bit owner. If we calls to pet, this is reference bit owners, bit owner, reference address.yaml. So let's build a honeypot based on this configuration. Right, let's has CLI generate honeypot swagger, and let's call it honeypot swagger 1, and we supply tag as the path for the main Swagger file. It's important, the main file, not any file. And here we go. So this is generated. Let's have a look what we just generated. There is in it the YAML, of course, and there is a couple of templates. We will have here like the bit YAML, which contains the get and post for bits endpoint, and JSON file with randomized content for each of this request. Here we found an array for bits. The length of the array and the content is totally randomized, and we have the content of the post, and we have bit/name, which is parameter, and we have the randomized content for this endpoint. If you noticed that hash is smart enough to pick it that there is a parameter, dynamic parameter here in the URL, and this needs to be reflected in the corresponding field here. So this will be the same as the parameter goes in the URL. So let's test it and see. I run what we call it, Honeypot Swagger, and let's open it. Bits, you'll find here, this is the list of the bits with a randomized content. And if we go, for example, this, and we'll find here the name, birth date, and owner, and address. All of this is generated automatically. And if we go for the first one, for example, you will find here the same. The name in the URL is reflected in the JSON response. To recap, we had a look at hash and how you can generate and customize honeypots to simulate any HTTP software you want. And we announced a new feature to automatically generate honeypots from Swagger files directly. Please feel free to navigate the source code, and contributions are welcome. And of course, start the project if you like it. Thank you and have a good rest of your day.